Now, coming to the boiling points of dihalobenzenes. See, if you observe the boiling point of dihalobenzenes, ortho is greater than para is greater than meta. Okay. As far as melting point is concerned, look at the arrangement, order. So melting point wise, you know, para is maximum, then comes ortho, and finally the meta one. See the basic difference. First, in case of boiling point, it is ortho para. In case of melting point, it is para ortho. See, the para isomer has got a higher melting point than the ortho one. It is because of the symmetry that it has. In general, boiling point is explained on the basis of polarity, right? Dipole moment. Greater the polarity, greater is the boiling point. But when it comes to melting point, it is explained on the basis of symmetry. Yes.
ఆల్రెడీ తెచ్చింది అది.
Now, let us go for density. See, density increases with increase in the number of halogen atoms. Okay. For example, you can take methylene chloride, chloroform, carbon tetrachloride. With carbon tetrachloride having the maximum density. Density also increases with the number of carbon atoms. Increases with increase in the number of carbon atoms. It also increases the atomic weight of the halogen atom. Okay. This is all about the density. Now, let me go for the chemical properties. See, the chemical properties are very, very interesting. Let us first go for the reaction with aqueous KOH. Okay. See, with aqueous KOH, alkyl halides give alcohols. Let me give you the equation. You can also use sodium carbonate, whose aqueous solution is again alkaline. Anyway, you get sodium hydroxide again. So here you get ROH. X minus, a weaker nucleophile is replaced by OH minus, a stronger nucleophile, SN2. Okay. Now, let us consider alcoholic KOH. Aqueous, now it is alcoholic. We know that the alcoholic KOH is a dehydrohalogenating agent, right? Now with alcoholic KOH, will have elimination reaction. Let me give you an example. See, in this case, it will be E2, isn't it? Now take the OH minus, as and when this OH minus attacks or abstracts the proton, this is what actually happens, and we get ethylene. So aqueous KOH gives a substitution product, alcoholic KOH gives elimination product. Now, with the dry silver oxide, with the dry silver oxide, we get ether. So in this case, we get R, O, another R with silver halide as the byproduct. So a preparation method of ether. This is what we get with dry silver oxide. Now let us go for reaction with moist silver oxide. moist. See, when I say moist, it will be silver oxide plus water. We get silver hydroxide. This will now react with the alkyl halide to form alcohol. Okay, so interesting. With the dry silver oxide, we got ether. Now with moist silver oxide, we got alcohol. We have already seen two pairs, aqueous KOH, alcoholic KOH, dry silver oxide, moist silver oxide. Now let me give you reaction with alcoholic potassium cyanide. You know, potassium cyanide is ionic. It can be given as K plus Cn minus. Okay. Now, when this is treated with alkyl halide with ethanolic KCN forms alkyl cyanide as a major product. Cyanides are major. Cn minus replaces X minus, SN2 again. Okay. Cyanides are major, and of course, some amount of isocyanides, minor. Now, if we carry out the reaction with aqueous ethanolic silver cyanide, you know, silver cyanide is covalent. Potassium cyanide is ionic. Silver cyanide is covalent. Okay. It can actually be given as Rx plus AgCN. Now this is what is going to attack. Okay. So here the attack is through nitrogen atom. Earlier the attack was through carbon atom in case of potassium cyanide. Okay. Now, in this case, we get isocyanides as major. And of course, cyanide as minor. Okay. So, KCN, silver cyanide. Now, with potassium nitrite, see, alkyl halides react with potassium nitrite. Let me give it this way. Now it is again ionic here. Potassium nitrite in the presence of DMF, dimethyl formamide, which is a polar aprotic solvent. Now in this case also, SN2 is what happens, and we get alkyl nitrite as the major product. And the nitroalkanes are minor. Okay. Then with silver nitrite. Now silver nitrite is covalent. In this case, we get nitroalkanes as the major products, whereas the alkyl nitrites are the minor products. Okay. So these are the very interesting reactions. All four different pairs of reagents. Okay. Now, the reaction with ammonia. This is, of course, called Hoffman's ammonolysis. See, when alkyl halide is taken in excess, reacts with ammonia. To form, see here NH2 minus replaces or substitutes the X minus, SN2, RNH2 plus HX. Okay. Now this RNH2 further reacts with alkyl halide to form R2NH plus HX. You get a secondary amine. In the first step, we got a primary amine. Now it's the secondary amine. Now this R2NH further reacts with alkyl halide to form R3N plus HX. A tertiary amine is what we get. Now this tertiary amine further reacts with another molecule of alkyl halide. See, we got nothing to eliminate now. So they just form a salt. R4N plus X minus. You know, this is a quaternary ammonium halide. So this way, the reaction goes heavily until a quaternary ammonium salt is formed. Now let me give you some SN2 reactions. Look at these. Alkyl halide reacts with sodium thiol, SH minus, substitutes X minus, and forms alkane thiols. So this is alkane thiol. Thiols are also called mercaptans. Okay. Now we can just modify this. Plus ASR. We get RSR. If you want, you can just prime this. So these are called thioethers. Now with sodium sulfide, let us take 2 molecules of this. Even in this case also we get thioether. Okay. Alkyl halide with a dialkyl sulfide. Even here also we get a mixed thioether. Along with this we get an alkyl halide. Right. 1 R dash with this X. Next. See, the alkyl halide reacts with say silver carboxylate. We get R O C double bond O, then R dash. Of course, the silver halide. Then, see, alkyl halide reacts with sodium azide, Na, N3, Na plus and N3 minus, SN2. We get alkyl azide. Along with this, we get sodium halide. So these are all SN2. I still have some more. Now, see, alkyl halide reacts with sodium alkynide to form R C triple bond C R dash plus NaS. Okay. So these are the SN2 reactions. Next. See, we have reactions with metals. Alkyl halides with lithium metal, we get alkyl lithium. Okay. Along with this, lithium halide. Similarly, with magnesium metal, well known, we get alkyl magnesium halide. Grignard reagents. Now, a specific reaction wherein ethyl chloride reacts with lead sodium alloy to form tetraethyl lead. Simply given as TEL, TEL. We'll also get sodium chloride and of course lead. You know, this tetraethyl lead is used as an anti-knocking agent. We have seen octane number in alkanes. You know, this TEL is added to petrol in order to prevent knocking, explosion. Okay.